Hey everyone, and welcome. Have you ever dreamed of building your own smart home gadget? Maybe a custom fitness tracker, or even a robot that you can control with Wi-Fi? Well, the key to unlocking all those projects, it might be a lot smaller than you think. Today, we're diving into the ESP32, the tiny but seriously mighty microcontroller that's become a total powerhouse for makers everywhere.
So let's just take a look at it. This right here is a NodeMCU development board, which is probably the most common way you'll see the ESP32. I mean, look at it. It's incredibly compact, about the size of your thumb. But as we're about to find out, it is absolutely packed with an incredible amount of power.
And seriously, calling this thing a beast is not just hype. It doesn't matter if you're just a hobbyist tinkering on the weekend or a professional engineer. The ESP32 just hits that perfect sweet spot. It delivers this amazing combination of performance, features, and affordability that's made it the go-to brain for countless IoT projects.
Okay, so how does this little powerhouse actually interact with the outside world? Let's take a look at its anatomy, starting with the pins, the things that let you connect all sorts of sensors, displays, and motors.
Now I know, at first glance, a diagram like this can look a little overwhelming, but just think of it as a map of pure possibility. Every single one of these pins is a potential doorway to a sensor, a light, a motor, or pretty much anything else you can dream up. This is where the ESP32 meets the real physical world.
So let's break down what these pins can actually do. We've got a ton of analog to digital converters, or ADCs, which are crucial for reading sensors that measure things like temperature or light. It also has digital to analog converters, DACs, which are great for smoothly controlling stuff like the brightness of an LED. And of course, you get all the standard communication protocols. There's UART, which is kind of like a simple direct chat between two devices. You've got SPI for super fast data transfers with things like an SD card, and I2C, which is amazing for connecting a whole bunch of different sensors using just two wires. Oh, and it even has built-in pins that can detect touch. This versatility is what makes the ESP32 such a monster.
All right, all those connections are awesome, but what's actually running the show? Let's move from the outside in, because the core engine of the ESP32 is where it really leaves its predecessors in the dust.
That's right, dual core. For a microcontroller this small and this cheap, having two processor cores is a massive game changer. It means you can have one core totally dedicated to a demanding task, like managing a rock-solid Wi-Fi connection, while the other core is free to just run your main code. Think about it. Your smart thermostat can be downloading a firmware update in the background without ever stuttering or failing to check the room temperature. That's the power of dual core.
But here's where the real magic happens. Unlike a lot of older boards where you had to add extra shields or modules, the ESP32 has wireless connectivity baked right into the chip. And you don't just get Wi-Fi, you get two different kinds of Bluetooth. Classic for things like streaming audio, and Bluetooth Low Energy, or BLE, which is absolutely perfect for battery-powered gadgets.
So this brings us to the two superpowers that truly set the ESP32 apart. It's not just that it has these features, it's how it uses them that opens up a whole new universe of projects.
Let's start with Bluetooth Low Energy, or BLE. Its superpower, as you might guess from the name, is its incredibly low power use. See, regular Bluetooth is always on, always chatting. But BLE devices spend most of their time in a deep sleep, waking up for just a split second to send a little burst of data. This incredible efficiency is what makes it possible to build sensors that can run for months or even years on a tiny little coin cell battery.
And the way BLE organizes this data is actually pretty genius. It uses a structure called GET. Just think of it like this. A service is the type of device, like a heart rate monitor. Then a characteristic is a specific piece of data that service provides, like the heart rate value. And finally, the value is, well, the actual data, like 120 beats per minute. It's just a really simple and organized way to handle information.
Right. This is the question every maker thinks of. We've got a dual-core processor, we've got two wireless radios. Surely this thing must just chew through batteries for breakfast, right? Well, that is where the ESP32's other superpower comes into play.
This table really tells a powerful story. In active mode, when Wi-Fi is blazing and the CPU is working hard, yeah, the ESP32 draws a fair bit of current. But here is the magic trick. Look what happens in deep sleep mode. The power consumption just plummets to almost nothing.
Let's just focus on that number for a second, around 10 microamps. That is an unbelievably tiny amount of power. To put that in perspective, that's over 10,000 times less power than when it's actively sending data.
This is the secret sauce. This is what makes long-term battery-powered IoT projects not just possible, but actually practical. Okay, so let's bring this all together. We've got more processing power, we've got more connectivity options, and we have incredible power efficiency. To really see the payoff, let's put the ESP32 head-to-head with its famous older sister, the ESP8266.
This comparison really lays it all out. Look, the ESP8266 was a total game changer, no doubt about it. It brought cheap and easy Wi-Fi to every maker. But the ESP32 just takes everything to a completely different level. You're not just getting a faster dual-core processor, you're getting Bluetooth built right in. You're not just getting a handful of pins, you're getting over 30 of them to connect more stuff. And the ability to read analog sensors is just worlds better. It really is a true evolution.
So does this mean the ESP8266 is obsolete? Not at all. It's still a fantastic choice for simpler projects. If you're building something on a really tight budget and all you need is basic Wi-Fi and a few simple controls, the ESP8266 is still a super solid, cost-effective option.
But let's be honest, for most modern projects, the ESP32 is just the way to go. If your project needs Bluetooth, if it has to handle complex tasks or juggle a bunch of different sensors, then the extra power and flexibility you get from the ESP32 are absolutely worth the small extra cost. It just future-proofs your work.
So there you have it, a dual-core, Wi-Fi, and Bluetooth-enabled computer that can run for years on a battery, all in a package that costs just a few bucks. The only real question left is, with all this power in your hands, what are you going to build with it?